So completely factoring an expression usually means there's more than one method that you're going to use. In other words, you can't just factor once and assume you're done. You have to keep on factoring. How many different methods have we learned so far? Let's think about this. Pulling out a GCF is the easiest, okay? We learned difference of squares, sum of cubes, difference of cubes, and factor by grouping. The last one would be the X method. We've learned all of those. So we're going to be using all of those in this lesson to completely factor an expression. But as I've been saying all along, the first thing you should always do is look at what you're given, see if you can pull a GCF out. So that's going to be our first step in the lesson. That's always the first thing you do. So for the first example, it says factor 1029 x cubed y plus 24 y to the fourth. So again, the first thing you should always do is look at the expression, see if there's a GCF you can pull out. Now again, there's a trick for seeing if 3 goes into a number. Add the digits, right? So for the first one, it's not obvious that 3 goes into it, but when you do 1 plus 2, you get 3, plus 9 is 12. 3 goes into that, so we know it goes into 1029. And then the other one, 24, we know that goes into it 8 times. So we can pull a 3 out. Furthermore, they both have a y, so we know we can pull a y out as well. We cannot pull out an x, because this term does not have an x in it. So when we pull out a 3y, this divided by 3 is 343. 24 over 3 is 8. And then when we divide this by a y, the y goes away, so you just have x cubed. And this divided by y would be y cubed. So we have 3y, which is the GCF we pulled out, times 343x cubed plus 8y cubed. So again, that's just step one. We want to completely factor the expression. So basically, once you pull that GCF out, you're going to look inside the parentheses to see, can you factor that? So what do you think? Using what formula? How can we factor 343x cubed plus 8y cubed? Which formula would that be that we use? Huh? No, you cannot use the x method because it's only got 2 terms and there's more than one variable, so that doesn't work. We've already pulled out GCF, so that doesn't work. How about factor by grouping? No, you need 4 terms for that. How about, what? Can you use difference of squares? Well, no, obviously not. That's a plus. So we only got 2 options left. Yeah, sum of what? Sum of cubes, yes. And, 343 is actually a perfect cubed. It's 7 times 7 times 7. And 8 is a perfect cubed. It's 2 times 2 times 2. And then the powers are 3. That's actually a pretty good hint. If the powers are 3, it's probably going to be difference or sum of cubes. Since there's a plus sign there, it's going to be sum. Step 2, I just say factor, factor, factor. In other words, you're going to keep factoring until you can't factor anymore. So that means for the middle expression, you're going to take the cube root of the first expression. Again, the cube root of 343 is 7. Cube root of x cubed is x. So your a, going back to the sum of cubes lesson, is 7x. Take the cube root of the second expression, cube root of 8y cubed, you're going to get 2y. So I'll give you a second to copy that, but just remember that this is your sum formula. A plus b, a squared minus ab plus b squared. And then I've got this labeled right here. Don't forget the original GCF you pulled out is going to be in your final answer. So I just put it outside of that formula. Okay, so now all we have left to do, right, is just plug in a and b into these, into this formula. So every time there's an a, plug in a 7x. Every time there's a b, plug in 2y. So there's the substitution. Remember, every time you plug those in, put them in parentheses. For the first set of parentheses, doesn't really matter. It's just going to be a plus b, 7x plus 2y. But right here, we have a squared. It's 7x squared. Both of these become squared, so it's 49x squared. In the middle, we have 7x times 2y, ends up being minus 14xy. Final term, b squared becomes 4y squared. And just remember the original GCF you pulled out is included in your final answer. Now this gets asked all the time, can we factor this? Once you use the sum of cubes formula, can we not use the x method? The answer is no, okay? You can try it, but whenever you use sum of cubes, you will never be able to factor this. It's just done, okay? There's not a third layer of factoring after using the sum or difference of cubes. So this will be your final answer. What's step 3 say? Check by going back through your work. So that's what I'm going to do. Did I pull out the right GCF? Yes. Did I put the right thing in the parentheses? Yes. We could kind of just mentally check and make sure that multiplies back. Did I use the correct formula? Yes. I used sum of cubes. I would not use difference of cubes. I found the correct A. I found the correct B. Sum of cubes is plus minus plus. I'm good there. And then finally, I'm just checking to make sure I plugged it back in correctly. That's a lot easier actually than trying to re-multiply all this stuff out. That would just be insane. Of course, you will get the original problem out, but it's just too much work. It's easier to just check back through your work sometimes. Example 2. And we only have 2 examples today. Factor 20x cubed minus 12x squared minus 45x plus 27. Okay, so the first step says to pull out a GCF. So let's think about this. We could almost do 3, right? But 3 doesn't go into 20. Then we can try 2. But 2 doesn't go into odd numbers. 4 is not going to work. 6 is not going to work. Maybe 9. No. So there's no GCF. This doesn't have an x term, so I can't pull an x out. So this illustrates you want to pull out a GCF if possible. If not, move on to the next method of factoring. So since we have 4 terms, what method would we use? Factor by grouping. This was the lesson we just went over. The GCF of the first 2 terms is going to be 4x squared. Okay. We are left with 5x minus 3. Whoops, wrong slide. The GCF of the next 2 terms is going to be minus 9. We're going to also be left with 5x minus 3. So since we end up with the same thing in the parentheses, that's one factor. 4x squared minus 9 is the other factor. So I have this underlined. Okay, why? Because the step says factor, factor, factor. Obviously 5x minus 3 is done, but what about the 4x squared minus 9? Which formula would you use for that? 4x squared minus 9. Which method of factoring? Can you use the x method? No. 2 terms, right? Can you use the difference of cubes? No, these aren't perfect cubes. Which one can you use? Yeah, so there's a minus sign there. That means difference, right? There's an x squared here, so it's a pretty good indication we're going to use difference of squares. Is 4 a perfect square? Yes, 2 times 2. 9 is a perfect square, 3 times 3. So you can use the difference of squares to factor this.
Are we going to have to do that today?
Yeah.
So would it turn into 2x squared minus 3?
Close.
Or
2x minus 3, yes, 2x plus 3. In other words, you take the square root of the first term to get your a, which is 2x. Take this square root of your second term, 9, to get b, which is 3. So your a is 2x and your b is 3. Using the difference of squares, it's a plus b, a minus b. So it's 2x plus 3, 2x minus 3. And that's just breaking down the first factor. Again, the second factor, you can't factor 5x minus 3. That's just it. And so for this particular example, we used factor by grouping first, and then we used difference of squares. We end up with 3 total factors. So I'm going to go back through and check my work. Again, if you have 4 terms, the only method you can use is factor by grouping since there's no GCF. Okay, I pulled out the correct factors here. Ended up with 2 sets of parentheses, looks good. Then I use factor by difference of squares. to figure out my last set of parentheses. So again, if you were to remultiply all this stuff out, you'd end up with the original problem. Oh, there's 3 examples. I'm sorry. There's a 3rd example. Okay. We have 2x to the 6th power minus 8x to the 4th power plus 16x cubed minus 64x. Again, you want to check to see if it has a GCF. They're all even, so I know I can pull a 2 out. Now I can't pull a 4 out because of this 2, right? So it's just got to be 2. And then x is the biggest power, x to the 1st, so I can only pull out a 2x. That leaves me with x to the 5th minus 4x cubed plus 8x squared minus 32. And again, we have 4 terms. Only method we know to do that is factor by grouping. So the GCF of the first 2 is x cubed. I'm left with x squared minus 4. Yeah, this is a pretty involved problem. And then the GCF of the next 2 is 8. If I pull an 8 out of that, I'm left with x squared minus 4. And since both of these are x squared minus 4, see if I can underline that. That will become one factor. And then the x cubed plus 8 becomes the other factor. So I'm going to pause there for a second and just reiterate. We pull out a GCF first, and then we factored by grouping. And now we're here. But again, remember, factor, factor, factor. You want to factor until you know for a fact you can't factor anymore. So let's look at this first factor we pulled out, 2x. Well, obviously you can't factor 2x. It's just 2x. But what about x cubed plus 8? It's the sum of cubes, okay? So we'll focus on factoring this as well. We will figure out a and b. A is the cube root of that, which is x. B is the cube root of that, which is 2. And again, I'll give you a second to copy that. Who remembers the formula for sum of cubes? I should just add it.
Plus minus plus.
Good. Plus minus plus. So a plus b, a squared minus ab plus b squared. Right. So there it is. A plus b, a squared minus ab plus b squared. Notice I'm keeping the original GCF. I'll pull it out, and the other factor we'll deal with in a second. So it's going to be x plus 2 times x squared minus x2 plus 2 squared, which becomes still the original GCF 2x times x plus 2, x squared minus 2x plus 4. So again, like I said, once you use the sum or difference of cubes for that particular factor, you won't be able to factor that anymore. I mean, I know this looks like you could use the x method. Trust me, you can't. It won't work. You'd have a 4 on the top of your x and a negative 2 on the bottom. You won't be able to complete it. So again, once you use the sum or difference of cubes on a particular factor, you know that's done. However, we still have this original x squared minus 4. What method can you use to factor that? Difference of squares, right? I think we've done this enough by now to know this. It's going to become x plus 2, x minus 2. So we actually used 4 methods in this problem. We first pulled out a GCF, then we used factor by grouping, then we factored the first expression using the sum of cubes, and finally we factored the last expression using the difference of squares. We end up with 1, 2, 3, 4, 5 total factors. Again, I'm actually going to go back and check my work just to make sure. GCF looks right, and then grouping looks good. Then I use sum of cubes, that's right. Then I use difference of squares. So we started with this expression, and we ended up with this, which is equivalent, right? It's just broken down more.